Jai Hind. Jai Hind. Myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss the topic solar collectors. So, in this lecture, first of all, I will discuss what is solar collectors. Then, what are the classifications of solar collectors? Then, what are non-concentrating collectors and their types? And in last, I will discuss what is concentrating collectors and their types. So, what is solar collectors? Basically, solar collectors are used to collect the solar energy and convert this energy into thermal energy by absorbing heat. So, the heat is absorbed by flowing fluid in the tube of collectors. There are further solar collectors are classified into two types. First one is non-concentrating type collectors and second one is concentrating type collectors. So, in subsequent slide, I will discuss what is non-concentrating collectors and what is concentrating collectors in detail. So, what is non-concentrating collectors? So, basically, in this collectors, the area of collector to intercept the solar radiation is equal to the absorber plate and has concentration ratio of 1. So, this type of collectors are called non-concentrating type collectors. Further, non-concentrating type collectors are categorized into three types. These are number 1, flat plate type collectors, vacuum tube collectors and unglazed flat plate collectors. What is flat plate collectors? So, these are the most important part of any solar thermal energy system, which is flat plate collectors. It is simplest in design and absorbs direct and diffuse radiation both and converts these radiation into useful heat. It is suitable for heating the temperature below 100 degrees Celsius. This is the pictorial representation of liquid flat plate collectors. If you are talking about its components, so here this is the absorber plate, this is fluid passage, this is thermal insulation, and here two types of radiation are impact. One is beam radiation and second one is diffuse radiation, and further these radiation are converted into heat by the help of this liquid flat plate collectors. Now, if we are talking about its disadvantages and disadvantages of flat plate collectors, so its advantages are, first one is it utilizes both the beam means direct as well as diffuse radiation for heating. So, it can deal with both type of radiation. And second one is it requires less maintenance. If you are talking about its disadvantages, the first one is large heat losses by conduction and radiation. So, here losses due to conduction and convections are more, no tracking of sun and low water temperature has achieved. So, this type of collectors are suitable for low temperature application, means below 100 degrees Celsius. The second non-concentrating type collectors are vacuum tube collectors. What is vacuum tube collectors? It looks like fluorescent lamp, contains several individual parallel glass tubes. Each tube contains an absorber tube bounded to a heat pipe which is covered with selective coating and suspended in vacuum. Now, these tube collectors are more efficient than the flat plate collectors because they perform well in both direct and diffuse solar radiation. So, we can say that vacuum tube collectors are more efficient than flat plate collectors. These collectors are also best suited for moderate temperature application where the demand temperature is above 95 degrees Celsius and very cold climates. As we know that flat plate collectors are suitable for low temperature application, whereas these type of collectors are more suitable for moderate temperature application like temperature above the 95 degrees Celsius and for cold climate condition. This is the schematic representation of vacuum tube collector. Here, this is the glass metal seal. This is glass metal seals. This is here fluid in and from here fluid exit. This is the selective surface. This one is selective surface and entire space are evacuated. Okay. So this is the vacuum tube collector. Now, the third type of non-concentrating collectors are unglazed flat plate collectors. Unglazed flat plate collectors. Here, basically these type of collectors are designed for low temperature applications such as the heating of swimming pool, etc., where demand of temperature is at below 300 degrees Celsius. So, this type of collectors has been used for temperature below 300 degrees Celsius. Made up of either rubber or UV stabilized black polymer plastic. A large portion of sun's energy is absorbed and lost both due to the absence of glazing. This type of collectors having lifespan of 15 to 20 years. This is the schematic representation of unglazed type flat plate collectors. Now, I will discuss what are the materials needed for flat plate collectors. So, the materials needed for flat plate collectors are classified into following groups. The first one is physical property, then thermal property, then environmental property. Means the material for flat plate collectors should have physical properties, thermal properties as well as environmental properties. So in physical properties, the material should have tensile strength and density. In thermal property, the material should have thermal conductivity and heat capacity. And for environmental property, the material should have corrosion resistant, degradation of material due to UV radiation, moisture penetration, etc. So, the material generally used for various components of a flat plate collectors are given in subsequent slides. So, the first is for absorber plate and tubes. So, these plates should have high tensile strength, high thermal conductivity, and it should be corrosion resistant. So, for this purpose, generally copper, aluminum and steel are used. Then generally black chrome, black copper, copper oxide, black nickel, etc. are used for its coating to having high absorbability. Then for thermal insulation, so the material used for insulation should have low thermal conductivity, stability at high temperature up to 2000 degrees Celsius, and it should have non-corrosive. So, insulating material generally used for mineral wool, rock wool, glass, thermocol, foam, etc. Now, for transparent cover plate must have high strength, high solar energy transmittance and high durability against UV radiation. So, usually plain glass plates are toughened of 4 to 5 mm thickness are used. Now, for casing, this contains all the above components which is placed at angle facing south and inclination to the horizontal equal to the latitude of the latitude. So, it is made of aluminum, steel and fiberglass in rectangular shape. Now, for selective coating, this surface has high absorptivity of incoming solar radiation and low value of emissivity. So, selective surfaces are essential to reduce the heat loss from absorber plate and increases the temperature of absorbing surface, that is, it should have high collector efficiency. So, various methods of this coating which are employed are by electroplating, anodic oxidation, chemical conversion, etc. So, generally for coating, black chrome, black nickel, aluminum, nitride, etc. are used for this purpose. Now, I will discuss what are the different factors which can affect the performance of flat plate collector. So, the first parameter is incident solar radiation. So, here as the solar flux increases, the heat absorbed by the collector increases. So, thereby the performance of collector also improves. The second parameter is selective surfaces. So, by using materials for surfaces which are highly sensitive to the radiation, the absorption could be maximized, and the selective surface should able to withstand high temperature of 3000 to 4000 degrees Celsius, and it should not oxidize and not be non-corrosive. The second parameter is number of cover plates. So, the increase in number of cover plate reduces the internal convective heat losses, but also prevents the transmission of radiation inside the collector. So, more than 2 cover plate should not be used to optimize the system. Another parameter is spacing between absorber plate and glass cover. So, the more space between the absorber and cover plate, the less internal heat losses. The collector efficiency will be increased. However, on the other hand, increases in space between them provides the shading by side wall in the morning and evening and reduces the absorbed solar flux. Next parameter is collector tilt. So, the flat plate collectors do not track sun and should be tilted at angle latitude of the location for an average better performance. So, the collector is placed with south facing at northern hemisphere to receive maximum radiation throughout the day. Another parameter is fluid inlet temperature. What is fluid inlet temperature? Basically, as the inlet temperature of the fluid increases, the operating temperature of the collector also increases. So, this leads to the increased losses and decrease in efficiency. Then, next one is dust on cover plate. So, the efficiency of the collector decreases with dust particles on the cover plate because the transmission radiation decreases by 1%. Frequent cleaning is required to get the maximum efficiency of the collector. So, these are some parameters which affect the efficiency of the flat plate collectors. Now, I will discuss what is concentrating type collectors. So, these type of collectors are also known as focusing collectors. These are used for medium where temperature is 100 to 3000 degrees Celsius and high temperature above 3000 degrees Celsius application such as steam production for generation of electricity. So, we can say that for electricity generation, we can use concentrating type collector because here we can achieve the temperature above the 3000 degrees Celsius. The collector system comprises of a concentrator and absorber, which is also known as receiver. The concentrator is an optical system in the form of reflecting mirrors or reflecting lenses. The collector is installed with a tracking device for continuously following the sun. The receiver includes an energy absorbing surface, transparent cover and other accessories. The system receives the solar radiation on the large concentration area and focus it onto an absorber having relatively much lesser area. This type of system have high collector efficiency, which lies between 15 to 70%. So, compared to non-concentrating type collectors, concentrating type collectors have better efficiency and the efficiency lies between 50 to 70%. Now, concentrating type collectors are further divided into two categories: focusing type, concentrating type collectors, and non-focusing type collectors. Further, focusing type collectors are classified into parabolic through reflector, mirror strip reflector, Fresnel lens collector, and parabolic disc collector. And non-focusing type collectors also classified into two types, which is flat plate collector with plane reflector and compound parabolic concentrator. So in subsequent slide, I will discuss one by one in detail about different types of concentrating collectors. So what is parabolic through reflector? Basically, parabolic through reflector is a focusing type collectors. In this line focusing type, it is also known as line focusing type collector. In this type of collector, the solar radiation falling on the area parabolic. This is solar radiation falling on the line of the parabolic. This is parabolic. Solar radiation falling on the line of the parabolic reflector are concentrated at the focus of the parabola. This is the focus of the parabolic. All the lines are focused here, this point. So these are usually made of highly polished glass-like shine surfaces, and the temperature at the absorber tube is obtained at nearly 4000 degrees Celsius. So because of its parabolic shape, it can focus the sun at 30 to 100 times its normal intensity on a receiver. So by help of parabolic through reflector, we can concentrate the whole radiation at one point, and which is called focus of the parabola, and by the help of this type of concentrator, we can achieve the temperature at 4000 degrees Celsius. Now the second type of focusing type collector is mirror strip reflector type concentrating collector. So it has plain slightly curved mirror strips mounted on a flat base. The individual mirrors are placed at such an angle that reflected solar radiation fall on the same focal line where the absorber pipe is placed. So this is the mirror strip, and all the mirror strips focused the reflected rays at this point. So the collector pipe is rotated so that the reflected rays on the absorber remain focused with respect to changes in a sun elevation. So this is the mirror strip type, mirror strip reflector. The third one is Fresnel lens concentrating collectors. So in this collector, a Fresnel lens, this is called Fresnel lens, this is called Fresnel lens, which consists of fine linear groups. This is fine linear group. This is called fine linear groups on the surface of refracting material of optical quality on one side and flat on the other side. And the other side is flat. This is the flat side. The solar radiation which fall normally to the lens are refracted by the lens and are focused on a line where the absorber tube is placed. Here all the rays are focused here, and this is absorber pipe which absorbs the energy. So a Fresnel lens collector is generally made of acrylic plastic sheets having overall dimension of 4.7 into 0.05 meter. Now fourth one is parabolic disc collector. It is also a focusing type collector. In this collector, a point focusing type collector which has a mirror like reflector and an absorber at the focal edge. So this is called disc reflector, this is receiver, and this is water flow in, and this is the pipe for water flow out. So here the concentrating ratio of these collectors is 100, and the temperature of the receiver can reach up to 20,000 degrees Celsius. So these collectors have higher efficiency for converting solar energy to electricity in small power plant. So by the help of this parabolic disc collector, we can achieve maximum temperature. So this type of collector can be preferable for a small power plant. Now, if we are talking about non-focusing type collectors, it is also one of the type of concentrating collectors. So in this, if you are talking about flat plate collectors with plane reflector, so it uses a flat plate collector with a plane. This is flat plate collector with a plane mirror reflector attached to its edges to reflect the additional solar radiation into the receiver, and thus the total solar radiation received by the receiver is increased. So the mirror used are called booster mirrors, and this collector utilized direct and diffused both types of radiation and achieved fluid temperature higher by 300 degrees Celsius than in flat plate collectors. So this is the schematic representation of flat plate collector with plane mirror reflector. Second one is compound parabolic concentrator. So it is also called Winston collectors. It consists of two facing parabolic mirror attached to a flat receiver. It collects both direct and diffuse solar radiation with a high acceptance angle and requires occasional sun tracking. The temperature attained in the range from 1000 degrees Celsius to 1500 degrees Celsius, and the temperatures up to 2000 degrees Celsius can be achieved using the evacuated type of tubular absorber, and this is the schematic representation of compound parabolic concentrator. So, what are advantages and disadvantages of concentrating collectors over flat plate collectors? So, the first advantages is the cost of the concentrator system, unit area is less in the case of concentrating collectors. Concentrating collectors requires less absorber area compared to flat plate collectors. It has high collection efficiency since heat losses are less. Concentrating type collectors suitable for large power generation since high temperatures of the fluid can be attained. So for electricity generation, we can use concentrating type collectors. Now, if you are talking about its disadvantages, so the first disadvantage is the system needs tracking of the sun, which increases the capital cost, and diffuse solar radiation cannot to be collected on the receiver. Concentrating type collectors requires higher maintenance to retain the quality of reflecting surfaces compared to flat plate collectors. It has also high initial cost and maintenance cost compared to flat plate collector. So, this is all about for this lecture. Thank you for watching.